Hey y'all, I'm going to show you the inside of my car and how it all works. So currently I've got it working from a remote control. This remote control allows me to sort of control all the bits and pieces that I have inside here, including the ignition, to steering, the accelerator, brakes, and also the gears. But I'll go through it from the beginning. So over here I have a second battery. It's a deep cycle battery. This battery then allows me to sort of draw more power from the little battery that normally is in this car. I probably could have gone with a battery that is a cranking battery, but also deep cycle, but this was cheaper, so I went for this. So we've got a second battery set up. So we still have the same one in the front, but we also have this one here as an auxiliary battery with an auxiliary battery circuit. I have an isolator on here that I can control the power going to my system. That's really handy because then I can switch everything off. And then from there I go down to a fuse, a breaker, 50 amp breaker, that then feeds into this box. In this box here, we'll see that we have a bunch of electronics, and we'll go through those. So the components of the car, obviously you need steering, so we have the steering, gear selector, which we have an actuator here, accelerator is here, and brake is down under there. So one by one, the accelerator is controlled by a really high voltage, well not really high voltage, a high voltage, high torque servo controlled, connected to the accelerator throttle body. It's a carbureted car, so when I give it acceleration, it actually pulls on the cable, and that's connected directly to the throttle body, opening and giving more air to the car. For the gears, I change it by moving this one here, and I can select that gear by using this 3-position switch that I have here on this remote control. The accelerator is controlled by this stick here. Brake is controlled on the same stick, but it's pull back, and what happens is it moves the brake pedal in and out. It's a really slow actuator, and on my second car I'll actually put a faster moving actuator because the brakes are really slow to come on. It takes about 4 seconds to completely stop the car. 5 seconds really. But it works, and it's good enough for now. The steering is done by a custom setup that I made, which is done with this electronic power steering module here, with a steering angle position sensor that I've created here using 2 potentiometers that are geared to this gear that are directly connected with a belt. That then tells me, these are multi-turn potentiometers, I think they're 5-turn, yes. That tells me exactly where the car's steering angle is. This electronic power steering module is actually out of a Nissan Micra, so it's actually not a custom, it's actually a fitted thing that's in most modern cars. Since about 2006, I think they started making electronic power steering modules to replace hydraulic power steering modules. One thing, they were cheaper because they put less load onto the engine, are more efficient, I mean, for the cars because it put less load on the engines, and also they're kind of cheaper to make because electronic motors are just quite common these days. They normally gets powered by what's in here. That's normally a torque sensor that actually monitors how much pressure the steering wheel's been given by the user. With what I've done is I just give it direct commands to its power lines, they're red and black down here, via this Sabertooth 60 amp twin output controller. I just give it commands on where I want it positioned. It's either I can give it left or right by reversing the polarity. The motor controller is really good on this, but it's really kind of cool. We also have inside here, back in this box, another motor controller here. It's a 2x32 amp, which controls this actuator and also the brake actuator down there. And they're all really controlled by this Arduino Uno. That Uno is controlling the whole car's control system, including the ignition, which we have down here. Down here.
we have two relays, two 30 amp relays.
One of those relays controls the reds, which you can see here, the accessories are on. I have that on so I can move everything around. And the other one is for the ignition, so it actually hits the starter solenoid that fires the car. So, so we can actually do this. Oh, we've got it switched off so it won't work at the moment. But yeah, so that's how that works there. So it controls the reds. There we go, switch it on from there. And yeah, so that's how we get it running. So you can see a little bit of a cool acceleration thing. In my code I have a way of limiting how much accelerator it has, or increasing it as well. It also controls the positions using potentiometers for my brake and also on my gear selector. And also on my steering wheel position sensor as well. I also found that having an e-stop on the back of the car helps, no joke. It's a full emergency stop that I've hooked up because I had the car run away once because it glitched up. It was the radio lost transmission or receiver, there's some problem. I've since got rid of that receiver, but as a backup I've put an emergency stop on there. I'll just switch off the car. I also have over here on this box what's called a neutral switch. I put this in because if I had to move the car and I didn't have the receiver, or it glitched out, or I put it on the back of a truck and send it somewhere and I need the guy to get it on and off the truck, all the person needs to do is actually turn this isolator on, so turn it to the on position, and then if I hit this switch here and rotate it, I'll actually put it into neutral. So I'll show you. So now you can actually push the car around without even needing the receiver. I can switch the receiver off actually. And once they've got in position to put the car back into park, they just switch it back. And it's back in park position. So yeah, that's pretty much a bit of a run of how everything works in here. I think I've covered all bases. This took me just under 2.5 weeks to build, and I mean I was doing it part-time. If I was going to do this full-time, it'd probably take me less than a week. If I had all the components, had a mill lathe, I had to get some stuff outsourced. Big thanks to Rick Pruss. He allowed me to build everything in his big shed over there. I had to clean it out and make space, but it was really nice of him to do that, let me use that space. Also Noosa Metal Fabrication let me use their lathes and other tools down there, which was really fantastic. Also everybody else out there, Ben Sand, who told me that I should be doing this, because that's what I'm good at doing, so I started doing it and I really enjoy doing this. I can't wait to put the next controller into here, which makes us autonomous, so we start doing object detection of cars and other things, and also getting it going around a track using GPS coordinates, some basic stuff. I get it kind of really basically self-driving, a bit stupid, but it's a demolition destruction derby style car, so it should be good. There's so many other people out there that helped me get to where it is right now. It's going to be kind of cool fun to open source this and get everybody else building these cars, because that's what we need to be doing. We need to get more people building these robotic cars, because it's something that is the future, and there's a huge skill shortage, and it's not that hard. The barrier to entry isn't that hard. So yeah, thanks for joining. I'll show you more as I go along on this journey, and I look forward to seeing you build your own cars.